Hi students, welcome back to the class. So far we have learned about vector algebra, the properties of vectors, the initial and terminal points of vectors, magnitude of vector, and then vector addition, properties of vector addition, etc. So we learned all those things, and finally we learned about unit vectors, the unit vector in the direction of each axis, and so on. Now we are in a position to do some problems. So we can solve exercise 10.2. The first question is, compute the magnitude of the following vectors. So you are given with two vectors. Vector A is equal to I cap plus j cap plus k cap, and vector B is equal to 2i cap minus 7j cap minus 3k cap. So you have to evaluate the magnitude of these two vectors, and it is very easier for you if you know the formula to find the magnitude, and these two vectors are in the component form. Also we know that the magnitude of vector A is nothing but the square root of sum of the squares of each component. So 1 square plus 1 square plus 1 square. So magnitude of A is nothing but root 3. Now magnitude of B is equal to square root of the sum of the squares of the components. So 2 square plus 7 square plus 3 square. See, minus 3 the whole square is nothing but 3 square itself. Minus 7 the whole square is nothing but 7 the whole square itself. So don't bother about the sign. So it will be 4 plus 49 plus 9. Right. So 49 plus 4 is nothing but 53. 53 plus 9 is equal to root of 62. Sorry, 62. So we get magnitude of the vector B as root 62 as well as the magnitude of the vector A as root 3. So now we shall move to the next question. Now we shall check the next question. The second question is, write two different vectors having same magnitude. This is the most easiest question in this section. Write two vectors having the same magnitude. First of all, you can write any vector in the component form. Let it be more simple if you choose the coefficients as 1, or you can write any vector. For convenience, I choose all the coefficients as 1. I cap plus j cap plus k cap. Is this a vector? Of course it is a vector, since it has 3 components, and each component, each unit vector in the direction of axis as the component. Also the coefficient of each component is nothing but 1. Now we have to find another vector which has the same magnitude as that of this. For that, you just change the signs. So the next vector will be nothing but I cap minus j cap minus k cap. There is also another vector, I cap plus j cap minus k cap. Similarly, you can alter the signs, but always, as long as the coefficients are same, the vector have the same magnitude. See, here the magnitude is nothing but root of 1 square plus 1 square plus 1 square equal to root 3. Similarly, here also root of 1 square plus minus 1 the whole square is nothing but 1 plus 1. It is equal to root 3. So it's here also the magnitude is root 3. So the magnitude will never change as long as the coefficients are the same. You can alter the signs of the coefficients so that you will get new and new vectors each time. Now we shall move to the next question. The question number 3 is that write two different vectors having same direction. This is a very simple question. Suppose we want to write two vectors in the same direction. Just write any vector like 2i cap plus 4j cap plus 6k cap. To obtain a vector in the same direction as that of this vector, just choose any positive number. Let lambda is equal to 4. Then find lambda A. It is nothing but 4 into 8 I cap plus 16 j cap plus 24 k cap. This vector will be the same vector in the direction of this vector A bar. You can choose any lambda instead of this, any vector instead of this. Just find lambda A. Lambda should be a positive number so that we get this direction as same. If lambda is a negative number, the direction will be reversed. Okay. The next question is, find the values of x and y so that the two vectors are equal. So we have to find the values of x and y so that this vector is equal to this vector. It is very simple. We can equate the components. We know that two vectors are equal if and only if the respective components are equal. That is, x equal to 2 and y is equal to 3. So this is the value of x and y so that these two vectors are equal. Let's move to the next question. The next question is question number 5. Find the scalar and vector components of the vector with initial point 2, 1 and terminal point minus 5, 7. So we are provided with 2 points, say A and B. So we have to find the scalar and vector component. So first of all, we can find the vector component or the vector formula for these 2 points. For that, it is enough to evaluate the vector AB. We know that the vector passing through 2 points can be evaluated by finding the difference of the respective component points. So we have minus 5 minus 2 I cap plus 7 minus 1 j cap. So the third component is absent here, so we don't have any component having k cap. So it will become minus 7 I cap plus 6 j cap. So this is the 7 I cap and 6 j cap are the respective vector components, whereas the scalar components are nothing but the corresponding coefficients. So vector components are minus 7 I cap and 6 j cap, whereas scalar components are minus 7 and 6. So this is the answer of the 5th question. Now we shall move to the 6th question. And the 6th question is, find the sum of these 3 vectors. And we know that in order to find the sum of 3 vectors, it is enough to find the sum of the corresponding components and form it into a vector. So we shall find vector A plus vector B plus vector C is equal to I minus 2i equal to minus I plus I equal to 0 I cap minus 2 plus 4 equal to 2 j cap minus 6 equal to minus 4 j cap. So next one is 1 plus 5 equal to 6 minus 7 equal to minus k cap. 6 minus 7 equal to minus 1, so minus k cap. So the answer is nothing but minus 4 j cap minus k cap. So this is the answer. Now we shall move to the 7th question. The 7th question is, find the unit vector in the direction of the vector A is equal to I cap plus j cap plus 2k cap. We know that for any vector A, the unit vector A cap in the direction of A is nothing but A bar divided by modulus of A. Now we have A bar, so it is enough to find modulus of A. Modulus of A is nothing but root of, we know that the sum of squares of the components. 1 square plus 1 square plus 2 square, it is equal to root of 1 plus 1 plus 2, 4 equal to root 6. So we have A cap is equal to I cap by root 6 plus j cap by root 6 plus 2k cap by root 6. This is the unit vector in the direction of those 2 vectors. Now we shall move to the next question. Next, the 8th question, find the unit vector in the direction of the vectors vector PQ, where P is equal to 1, 2, 3 and Q is equal to 4, 5, 6. So we have to find a unit vector in the direction of the vector PQ. So first of all, we have to find the vector PQ. We know that whenever we are given with 2 points x1, x2, x3, y1, y2, y3, then the vector in the direction of that is y1 minus x1 I cap, y2 minus x2 j cap, y3 minus x3 k cap. This was our last class. So by that we have PQ is equal to 4 minus 1 I cap plus 5 minus 2 j cap plus 6 minus 3 k cap. Now 4 minus 1 I cap is nothing but 3 I cap plus 3 j cap plus 3 k cap. So this is our vector PQ. Now just like in the previous problem, we have PQ cap or the unit vector in the direction of PQ is nothing but the vector PQ divided by absolute value of the vector PQ. It is equal to 3 I cap plus 3 j cap plus 3 k cap divided by square root of 3 square plus 3 square plus 3 square, 3 square plus 3 square plus 3 square, that is 3 I cap plus 3 j cap plus 3 k cap divided by, what is this, 9 plus 9 plus 9, 27, root 27. So this is our answer. So the next question is question number 9. For given vectors A bar is equal to 2 I cap minus j cap plus 2k cap and B bar is equal to minus I cap plus j cap minus k cap. We have to find two vectors. Sorry, we have to find a unit vector in the direction of the vector a plus b. So first of all, we have to find the vector a plus b. 2 minus 1 is equal to I cap. Minus j cap plus j cap is nothing but 0 j cap. 2 plus minus 1 is nothing but 2 minus 1 k cap. So plus 1 k cap. So this is a plus b. Now a plus b vector in the cap, that is the unit vector in the direction of a plus b, is nothing but vector a plus b whole divided by modulus of the vector a plus b. Now vector a plus b is nothing but I cap plus k cap, and the modulus is nothing but root 1 plus 1 equal to I cap plus k cap divided by root 2 will be the unit vector in the direction of the vector a plus b. So we shall move to the next question. The next question is, find the vector in the direction of the vector 5i cap minus j cap plus 2k cap with the magnitude which has magnitude 8 units. So we have to find a vector which has magnitude 8 unit in the direction of the same vector. For that, we have to do steps like this. First of all, we have to find a unit vector in the direction of this vector. Let it be vector a. So we have a cap is equal to 5i cap minus j cap plus 2k cap divided by square root of, what is the magnitude? 25 plus 1 plus 4. It is equal to root of 25 plus 1 is equal to 26 plus 4 is equal to 30. So we have the unit vector in the direction is 5i cap minus j cap plus 2k cap divided by root 30. Now we have to find a vector which has magnitude 8 unit which is in the same direction as that of a. So b bar is equal to 8 into a cap. So 8 into a cap is nothing but 8 into 5i cap minus j cap plus 2k cap divided by root 30. Clear? So we have 8 into 5 is equal to 40i cap minus 8j cap plus 16k cap divided by root 30 will be the vector which is in the same direction that of a and has magnitude 8 units. So now we shall move to the next question. The 11th question of this exercise is, show that these two vectors are collinear. So we have to show that these two vectors are lying in the same line. We know that two vectors a and b are said to be collinear if we can find a lambda such that vector a is equal to lambda into vector b. Remember this result where lambda is a scalar. So by that way we can evaluate this like this. We can name this as a and b. See, in b we can take minus 2 outside, right? So we have b is equal to minus 2 into 2i plus 3j, sorry, minus 3j plus 4k. We took minus 2 outside. When we multiply with minus 2, it will become minus 4i plus 6j and minus 8k. So this vector is nothing but vector a. So it will become minus 2 into vector a. Sorry, vector a. Therefore, we can find a lambda where lambda is equal to minus 2 such that b is equal to lambda a. So we can say that these two vectors are collinear. Now we shall move to the next question. The 12th question is, find the direction cosines of this vector. So we have to find the direction cosines of this vector. We know that for any vector xi cap plus yj cap plus zk cap, the direction cosines cos alpha is nothing but x by modulus of a, and cos beta is equal to nothing but y by modulus of a, and cos gamma is nothing but z by modulus of a, right? So we have to find the absolute value or the magnitude of the vector at first. So we have modulus of a is nothing but root over 1 square plus 2 square plus 3 square, which is equal to root of 1 plus 4 plus 9. It is equal to root of 5 plus 9 is equal to 14. So root 14 is the modulus of the vector. So we have cos alpha is equal to, first component is 1 by root 14. Cos beta is equal to, second component 2 by root 14. And cos gamma is equal to, third component 3 by root 14. So these are the direction cosines of the given vector. The next question is question number 13. Find the direction cosine of the vectors joining the points a is equal to 1 to minus 3, b is equal to minus 1 to 1, directed from a to b, which means our vector is nothing but ab, directed from a to b. So first of all, we have to find the vector form. We know that whenever we are given with 2 points, we can find the vector form as minus 1 I cap plus minus 2 j cap plus 1 minus 3 k cap. So the vector is nothing but minus 2 I cap minus 4 j cap plus 4 k cap. Then we have to find the modulus of the vector in order to find the direction cosines, just in like the previous problem. So modulus of AB is nothing but square root of 4, 2 square equal to 4 plus 4 square equal to 16 plus 4 square equal to 16 again. So it is nothing but root 36. Therefore, the direction cosines are cos alpha is nothing but first component is minus 2. Minus 2 divided by root 36 is nothing but 6. So minus 2 by 6, it is equal to minus 1 by 3. Cos beta is equal to second component is nothing but minus 4. Minus 4 by 6, it is nothing but minus 2 by 3. And cos gamma is nothing but third component is 4. It is equal to 4 by 6 equal to 2 by 3. So these are the direction cosines of this vector. Now we shall move to the next question. Show that the vector I cap plus j cap plus k cap is equally inclined to the x-axis, y-axis and z-axis. This is the question. Question number 14. So from this, whenever we are asked about inclination or angles, we have to think about the cosine, direction cosines. First of all, we have to find the magnitude of this vector A. So magnitude of the vector A is nothing but square root of 1 plus 1 plus 1, which is 3. So square root of 3 is the magnitude of this vector A. So from it is it is very clear that cos alpha is equal to 1 by root 3, cos beta is equal to 1 by root 3 and cos gamma is equal to 1 by root 3. See, the direction cosines are equal, which means that the corresponding angles can have equal values, and hence we can say that this vector is equally inclined to the x-axis, y-axis and z-axis. So we shall move to the next question, question number 15 of your textbook. The next question is question number 15. Find the position vector of a point R which divides the line joining 2 points P and Q whose position vectors are A bar is equal to this and B bar is equal to this respectively in the ratio 2:1. First of all, we have to find when the division is internal, and then we have to find it when external. So this is m:n. So we know that the position vector is given by r bar. The position vector of the point R is nothing but r bar is equal to mb plus na divided by m plus n when the division is internal. So it is equal to m is equal to 2. 2 into minus I cap plus j cap plus k cap plus n into, that is 1 into I cap plus 2 j cap minus k cap divided by m plus n is nothing but 3. It is equal to minus 2 I cap plus 2 j cap plus 2 k cap plus I cap plus 2 j cap minus k cap divided by 3. It is equal to minus 2 I cap plus I cap is nothing but minus I cap, 2 j cap plus 2 j cap is nothing but 4 k cap, then 2 k cap minus k cap is nothing but k plus k cap divided by 3. This will be the answer when the division is internal. Now we shall check what will be the answer when the division is external. External division. We know the formula as mb minus na divided by m minus n. You can choose m minus n or n minus m, whatever it is. If we choose n minus m, then the numerator should be na minus mb, that's all. So it is equal to mb minus na divided by n minus m. mb is nothing but 2 into this, that is minus 2 I cap plus 2j cap plus 2k cap minus NA, that is I cap plus 2j cap minus k cap divided by m minus n is nothing but 1. Now minus 2i cap minus I cap is nothing but minus 3i cap. 2j cap minus 2j cap is nothing but 0j cap. 2k cap minus minus k cap is nothing but 3k cap. So this will be the answer when the division is external. So I hope you understood what is the position vectors of the vectors while the division is internal as well as the division is external. Just to understand that only difference is the difference in these two formulas. If you know these formulas, you can easily find the position vectors. The question is, find the position vector of the midpoint of the vector joining the points 2, 3, 4, Q4, 1, minus 2. So we have to find the position vector of the vector of the point which divides the line joining these two points into two halves, midpoint. So the ratio of division will be 1:1 because it is the midpoint which we got when we after division. So it is an internal division, also known that it is the midpoint. So the ratio of division is nothing but 1:1. First of all, we have to find the position vectors of the point P and Q. Now the position vector of the point P is nothing but 2i cap plus 3j cap plus 4k cap, and the position vector of the point Q is nothing but 4i cap plus j cap minus 2k cap. Now we know that two vectors which are divided internally in the ratio m:1, and then the new vector, then the position vector of the new point can be evaluated by the formula ma plus mb divided by m plus n, right? Here m is equal to 1 and n is equal to 1. So it is nothing but a plus b divided by 2. So the new position vector is nothing but a plus b by 2. So we are here, our a is this vector and b is this vector. So we have vector a plus vector b divided by 2 is nothing but 2 plus 4i. 2i plus 4i is nothing but 6i. 3 plus 1 equal to 4j cap. 4 minus 2 is nothing but plus 2k cap whole divided by 2. Here we can cancel 2. It will become 3i cap plus 2j cap plus k cap. So this will be the position vector of the point which divides the line segment joining P and Q into two equal parts. The example number 17. Show that the points ABC with the position vectors a cap, a bar is equal to 3i cap minus 4j cap minus 4k cap, b bar is equal to 2i cap minus j cap plus k cap, and c bar is equal to I cap minus 3j cap minus 5k cap respectively form the vertices of a right angle triangle. A similar question is done in the example section, right? So let me give you a brief overview of the question and you can do it by yourself. We are given with three position vectors a bar, b bar and c bar. Easily we can find AB, vector AB, AC and BC, right? So check whether this is the three sides of a triangle. Check whether it satisfies the triangular, it satisfies the Pythagoras theorem or not. If it satisfies the Pythagoras theorem, definitely it will be the vertices of a right angle triangle. If we get modulus of AB square plus modulus of BC square equal to modulus of AC square, then definitely AC is the hypotenuse, BC is the base and AB is the height. Similarly, we can have an equation like this. If we can have an equation like this, then definitely we can say that these three vertices are the vertices of a right angle triangle. So now I am giving you this as a homework. If you don't get the answer or if you have any doubt regarding this question, please ask me in the comment section or personal questions. So we shall move to the next question. The question number 18 is that in the triangle in the figure, which of the following is not true? First one is AB plus BC plus CA is equal to 0. And the second one is AB plus BC minus AC is equal to 0. We shall check whether these two are true or not, and then we shall check the third one. Suppose this is a triangle, then we have AB plus BC is equal to AC by triangular law of vector addition. AB plus BC equal to AC, right? From this we can directly have AB plus BC minus AC equal to 0. So the second one is correct. Now AC can also be represented as minus CA, right? CA is the vector which starts from here to here. This is CA. Minus CA is again the original vector AC. So AC can be represented as minus CA. So we have AB plus BC plus CA is equal to 0. So we can have this is also 0. And the last one is AB minus CB plus CA is equal to 0 or not, right? This is CB. First of all, we have to find AB minus CB. So minus CB is nothing but this. This is nothing but minus CB. So that vector which has direction reversed. So this is minus CB, right? Now AB minus CB is nothing but this. This is AB, this is minus CB. So this is AB minus CB by triangular law of vector addition. Now minus CA is nothing but this, the same vector which has opposite direction. So this is minus, sorry, CA, not minus AC, that is CA. So CA is nothing but AC in the opposite direction. So this is my CA. Now AB minus BC plus CA is nothing but the vector with this, that is AB minus CB plus CA. See, this vector has a magnitude. So this is not equal to 0. So and it is given that this is equal to 0. So this is the wrong option. Very simple if you follow the diagrammatical method. Now we shall move to the next question. Now we shall move to the last question. If A bar and B bar are two collinear vectors, then which of the following is incorrect? First option, B bar is equal to lambda A bar. Of course this is true. We know that whenever we have a vector A bar, when we multiply it by a scalar lambda, we got another big vector which is in the same direction as that of the original vector. So B bar is equal to lambda A bar is true by the definition of collinear vectors. Second one, A bar is equal to plus or minus B bar. Of course this is true, since plus or minus actually means plus 1 or minus 1, which is a scalar lambda. So B bar, A bar is equal to lambda into B bar, again the definition of the collinear vectors. So it is also true. Now the third option is the respective components of A bar and B bar are proportional. Of course true, since we obtain B bar by multiplying A bar with a scalar, which means that we are multiplying each component with the same scalar. For example, suppose that A bar is equal to I cap plus J cap plus K cap. 2A bar is also a collinear vector for A bar, and 2A bar is nothing but 2I cap plus 2J cap plus 2K cap. It is obtained by multiplying each component with 2, which means that the components are proportional. See, each component is twice that of the new vector, original vector, right? So of course the third option is also correct. The last option, both of the vectors A and B have the same direction but different magnitude. That's wrong option, because suppose this is a vector and this is a vector in an opposite direction, but these two vectors are collinear vectors, right? So collinear vectors can also have opposite direction. So that's the end of this exercise set. I hope you understood all the exercises very clearly. If you have any doubt regarding any question we discussed so far, you can ask me in the comment section. So I hope you understood. Thanks for watching. Stay tuned for the next video. Bye bye.